A month or so ago, we made public all of our reference architecture documentation that was previously reserved for customers. That's at docs.cloudposse.com. As part of this, one of the nice things that you have access to if you check this out are design decisions. So basically, within each one of these layers, there's a number of design decisions that are good things to be aware of when you go about implementing your architecture. We just updated a couple more of these design decisions. One was we dusted off some of our recommendations or some of the considerations for secrets management solution on EKS. Obviously, there are a million ways to do it. Our goal is not to enumerate all of the possibilities, but the ones that we see most commonly or pique our interest. So somebody might be asking, why do you need a secrets management for EKS? See, Kubernetes comes with secrets management. That is true. But if you want to treat your clusters as disposable, more like cattle, then you would be best served by having some of your secrets or most of your secrets be external to your cluster. At least the secrets, the source of truth for the secrets being external to the cluster. That's one of the reasons why we've gravitated over the years towards external secrets operator. And to this day, that is our go-to recommendation, is using the external secrets operator, which supports a plethora of backends to source your secrets and write those to your Kubernetes cluster. What's nice about external secrets operator, I think it even supports, it definitely supports SSM, which we predominantly use, ASM. I think it might support even 1Password. It supports multiple other backends as well. Now, when you use external secrets operator, you're provisioning an external secret resource. And that's a resource that's safe to commit to your version control. So what's really nice about this is that you can declaratively express all the secrets your app depends on in your Helm charts, manifests, and deploy those. Now, recently, I was made aware of and, kind of caught the tail between my legs. I was a little embarrassed, but Amazon has actually released their own implementation of something like the external secrets operator, a CSI driver for secrets that supports ASM and parameter store out of the box. Since we at Cloud Posse predominantly use SSM, I think opting for a native AWS supported offering that fits or meshes well within the AWS ecosystem might be a good alternative to the external secrets operator. Now, for those that are optimizing for, general solution that works in GCP, that works on AWS and Azure, AKS, then maybe the CSI driver approach doesn't make the most sense. But if you're operating on EKS, so much is very bespoke to AWS to begin with. I think it's a lost cause trying to build the lowest common denominator across platforms. The third option that we like to bring up, and it's interesting because we always try and have the idiomatic solution or the canonical solution in our reference architecture, this is the way to do it. But secrets management has been one of those areas where different engineering teams weigh the trade-offs differently. And when we say that we're going to store secrets in SSM, some of you might be wondering, well, great. Well, how did those secrets even get there? And that's a story for another time. But it is a story I'll briefly address in option 3, which is kind of nice, but has another trade-off. So option 3 is the SOPS operator. If any of you are familiar with the SOPS library, it came from Mozilla. It is a portable library that's used for encryption of any data, and it comes with a CLI, and it supports different ways of retrieving the private key, and you can actually encrypt using KMS and IAM. So what's really nice about the SOPS operator is you have this way of encrypting secrets locally, and then you can commit those secrets in your version control in this kind of opaque manner where you still have the shape of your Kubernetes manifest, but the values that are sensitive are encrypted. So this way, when you look at a Git commit, it's at least transparent in the sense that you know when values changed, you just don't know what those values were. But the downside is, of course, that now you have to go through a whole deployment process to roll out your secrets, which is a heavy-handed way to rotate things, where there'll be a period of time where your secrets in the cluster might be invalid if you're doing rotation. So that's one of the big trade-offs with that approach. Also, I forgot to mention that this is an operator that then runs in the cluster. And when you write the SOPS secret resource to the cluster, the operator picks that up, decrypts it, writes a native Kubernetes secret, and can use the KMS key that you use to encrypt it to decrypt it, and leveraging all the same IAM semantics that you have in AWS. So no hard-coded credentials anywhere. It works beautifully with IAM. So overall, it's a very elegant solution, but it only fits certain ways of looking at Secrets Manager. So I thought I'd just pause there. I mean, that's all I have in terms of our options. And one of the reasons or my motivations for bringing it up on office hours is other recommendations, maybe from the community that you use, that you like, and maybe we should consider adding as an option.
Two questions. One, I was wondering, does the AWS Secret support things like Vault?
No, so that, like I said, this is a the option 2 here. The CSI driver is very opinionated, obviously supporting AWS services natively. If you want things like Vault, the external secrets operator is the way to go. Yeah.